Lesson 19, BBB. We are solving multi-step inequalities. So we've done in the past up to two-step inequalities, and then we kind of took a break from it. We're coming back to it today. We're going to solve them and graph them. Alright, so this first part's not on your notes. I just want you to watch up there. 4w minus 7 equals 22. That's a regular equation. We all know how to solve this, right? Get rid of constant, get rid of coefficient. And then you get w equals answer. And you can write that as a fraction or a decimal. They are equivalent, so it does not matter. And then the inequality we actually did before as well. We already know how to do this kind of problem. You're going to solve it exactly the same way. Get rid of constant, get rid of coefficient. The only difference here is in an equation, your solution is going to have w equals one number only. That's the only number in the world you can plug in to make a true statement. But in an inequality, you can plug in 7 1/4 and make it true, or any number bigger than that. There's an infinite number of answers that would work. Okay? And if we always graph our inequality solutions to show that there isn't just one answer, there's that answer and everything to the right of it in this case. Why don't we graph solutions to equations? Because if you did, it's just a dot on a line. It's nothing really interesting. We don't have to graph it because there's only one answer. It's already clear with your solution. Okay? Alright, this we've also done before, so just do this really quickly with me. Right now we have 4 is less than 6. Is that a true statement? 4 is smaller than 6. Yep. If I add 4 to both sides, is it still true? Yep. If I subtract 4 from both sides, is it still true? Yep. If I subtract 10, is it still true? Negative 6 is less than negative 4. Negative 6 is smaller than negative 4. Yeah, that's true. Multiply both sides by 4. Still true. Divide both sides by 2. Still true. Multiply both sides by negative 3. That will give me negative 12 is less than negative 18. That's not true. That's false now. And if I divide both sides by negative 2, false. Negative 2 is less than negative 3. That's not true. So if you remember, there are only 2 that are false. What did we do? What was different here? Go ahead. Good. Right, we multiplied or divided by negative. So that conclusion that we drew in the past, we're going to remind ourselves again, is this. Whenever you multiply or divide by a negative number, you have to flip or reverse that inequality symbol. Go ahead and fill in the blanks on your notes, please. Whenever you multiply or divide by a negative number, you must flip that symbol. Alright, so let me prove that to you. This is slides you've seen before as well. Just do this with me on your notes. This is on your paper. 8 is greater than negative 3. That's true, right? So if I multiply both sides by negative, let's pick negative 2 just because it's small and easy. That will give me negative 16 is greater than positive 6. Is that true? No. Negative is not bigger than positive, right? This is now false, but I can fix that problem simply by flipping around that symbol. And now it's going to be true. Negative 16 is smaller or less than 6. All right, here's another one. 8 is greater than negative 6. This is currently true. But if I divide both sides by a negative number, I'm going to pick 2 again just because it's easy. This is now negative 4 is greater than 3. Again, is a negative number bigger than a positive number ever? No. So this is false. But if I flip that symbol around, I'll make it true. Yeah? So anytime you multiply or divide by a negative number, if you flip that symbol at the end, you'll make it a true statement. Okay, this is on your paper. I want you to just do this quickly with me. If I have this inequality, and I'm trying to think of answers that I can plug in for w to make it true, I'm going to try to just pick some numbers and plug it in and see if it works. So let's pick like 2. Negative 4 times 2 minus 7. This would be negative 8 minus 7, which is negative 15. Does this work? Is negative 15 bigger than 22? Nah, that doesn't work. So I can't plug in 2. That is not a solution. What is one that might work? -9. Let's try that one. This will give me 36 minus 7, which is 29. Is that true? Yep, that works. So -9 is a solution. Give me another one that might work. 17 over 38. Or 1738. 1738. This is going to be negative and negative. This is a negative number. Is that negative number ever bigger than positive? Nope, that does not work, Matt. That would work. Let's put in a negative number. You want to use that giant one, that's fine. This is now a positive some number. It's going to be obviously bigger than 22, right? So you can just plug in numbers and see if they work. But a more efficient way to do this, to cover all your bases, because there's a whole bunch of numbers that could work, right, is to actually solve it. So let's add 7 to both sides. Do this on your paper. We have 29 on the right side now. Divide both sides by -4. The thing I did to both sides is negative. So do I have to flip it? Yes or no? Yes. I divided by negative, which is the rule we just reviewed. So I need to flip my inequality symbol, and I have now W is less than or equal to 7 1/4. If I graph this, it would look like a closed circle because of that or equal to, which means my -7 1/4 is included as one of those solutions that if I plugged it into W, it would make it a true statement. And any number I pick on the left side of it, any number smaller than -7 1/4 would be true, like -1738, -9, -11, -10, -52. Those would all make a true statement. Okay, so the way you would show every single possible answer is to write it as an inequality and graph it with an arrow. Make sense? All right, so let's do number 1, please. This is actually a review problem. You know how to do this problem. Go ahead and do it. Mm-hmm. Good. Mm-hmm. Okay. We divided both sides by a positive, so it does not matter that the 42 is negative. That has nothing to do with the symbol. That just means our answer is going to be negative. But we divided by positive, so we don't flip it. Okay, so it's still going to be less than or equal to -3. And then your graph should be open or closed circle? Closed. Good. Because of that or equal to part of the symbol, that means that the -3 is one of the numbers you can plug in to make a true statement. And is my arrow going to the left or the right?
Left.
Left. Good. Less than or equal to would go to the left side. That's where the numbers that are smaller than -3 lie. Any questions about number 1? All right. This was one that you already knew how to do. We learned this problem already. Number 2 is a true multi-step inequality that we're doing today. There is more than 2 steps. The first step is to do what?
Combine like terms.
Good. Combine like terms. We have a -5x and a 2x. Put those together and then solve for x, please. Don't forget to graph it. All right, Kathy, tell us what you did.
Oh, okay, so when I combine like terms, I got -3x. And after that, I subtracted 6 from both sides of the
Mm-hmm.
and then I got -3x is less than 15.
Mm-hmm.
And then I divided both by -3, and then I got -5. X is greater than.
Good. X is greater than. We had to flip it because this time we did divide by a negative number. Again, the thing that you are doing to both sides was negative. So you need to flip it. And when you graphed it, is it open or closed? Open. Good. -5 is not included. So you would have to draw a line with a hole in it.
To the right.
Open circle. And then to the right, because that's where all the bigger numbers than -5 are. Okay? Number 3, go ahead and do that one as well. It is also combining like terms. If there is no number in front of a variable, what's really there?
1.
Good, that's a -1x. Please combine them.
So first I
Combine.
combine and then like term. So I got -4x minus 7.
Then
Is less than or equal to
greater than or equal to.
greater than or equal to 4 and 5 times.
Okay,
Then I add 7 to -7 and 4 and 5 times.
good.
Then I divided -4x, -4 to -4x and to 11.5.
Good.
And I got x is less than or greater to
Less than or greater than, what's that?
less than or equal to
Okay,
-2 and 875
thousands. Good, flipping that symbol. X is less than or equal to -2.875, or as a fraction, -2 and 7/8. These are both correct because they are equivalent answers. And in your graph, you can use either fraction or decimal, same thing. Open or closed? Closed. It has the or equal to, meaning that is one of the numbers you can plug in to make it a true statement. Left or right? Left. We want it to be less than. Any questions on number 3? Wonderful. Let's look at number 4. This has fractions, which is the most recent thing we've been working with. You're going to do the same thing. Combine like terms, solve for y, and then graph your solution. Go ahead and do this one with your partner. You can talk through step by step how to do it, okay? Ready? Go ahead. Combining like terms, again, there is no number in front of that y, so this is really a -1y. 1.5 minus 1 is half y, and then what I did here is I made those fractions into improper in the same step. Subtract 5/2 from both sides. I can't subtract the left side yet because they are not common denominators. What is the LCD? 6, which means this one I times 2, and this one I times 3. What is 10 minus 15? Be careful. Good. -5, 6 is less than 1/2 y. Next step would be to divide both sides by half. So this is now -5, 6 divided by half. I'm going to rewrite it as multiply by the reciprocal. I can cross divide. So this is now -5/3 is less than y. I did not flip the symbol because I divided by positive halves. This is -1 2/3 is less than y. Now typically we don't like the variable on the right side like that. It's not standard form. I like to have it with the y on this side. But before I write my answer, let me ask you this. Right now in my blue one, which one's the bigger one, the y or the fraction?
The y.
The y is the bigger one. So when you finalize your answer, make sure the y is still the big one. Okay? We just wrote the entire thing backwards. Don't change the symbol though. It looks like it flipped, but it didn't really. The y is still the bigger one. And then when you graph it, I just need the 0 as a reference, and then my -1 2/3. Will it be open or closed? Open. Good. It's not included. And then left or right? To the right. We want it to be greater than that. Yes?
On our homework, what if we do it the other way, like, before we change?
It's okay as long as your symbol is facing the correct greater than one. Like this one, as long as y is the bigger one, then either way is good. Okay? So here again, I have divide by positive, so nothing flips. And you can write your answer like this, or standard form would be with a y first. Again, making sure the symbol is still like eating, like the alligator is eating the y. And then your graph is open to the right. Okay, number 5, distributive property. Distribute and then solve, please. Distribute. Mm-hmm. Good. Very nice. So far, so good. Put the x on the left side, like it was. Very good. X is greater than or equal to -1, and then when you graph it, it should be a closed circle on -1 because that is included in the answers, pointing to the right. Very good. Any questions about this one? Who got this right?
I did.
Awesome, awesome. Okay, we're going to skip number 6 and skip number 7. Go ahead and do number 8. What I want you to do in number 8 is there are 2 separate problems. They are easy, just one-step inequalities. And I want you to see if one of them, both of them, or neither of them have a solution of x is less than or equal to 4. Be careful of the symbol and be careful of the sign, positive, negative. The answer is B, both of them. Very nice. C, sorry, both of them. C, both of them. I'm sorry. All right, number 2, you're up first. What did you learn today? Ready? Share.